Welcome to this minor series video. We are going to be looking at the solutions of a mock test on exponents and sets. Don't forget to like and subscribe on the channel so that you are updated every time we upload a video. So this is the questions that this video provides solutions for, and I'll suggest that if you haven't tried the test, perhaps you should try it before watching this video. You can just pause it and then look at the solutions after. It's meant to be done in 30 minutes. The first question. So in this first question, what you notice is that you have a division sign, which means you have to apply the quotient rule, and you have a multiplication sign, which means you can apply the product rule. And also, if you look at 27, it's not a prime number, it's not a prime base like 3, but it can be written using the power rule. That will also apply for 9. So if you change 27 to a base 3, it will be 3 exponent 3, as well as if you change 9, it will be 3 exponent 2. If you further simplify, so you will multiply here 3 with x, that will give you 3x, and 3 with 2, that will give you 6. And you do the same in the denominator, where you'll have 2 times 3x, which will give you exponent 6x. And because you are only multiplying and dividing, you can apply the two rules, which are your quotient rule and product rule, at the same time. So x plus 3x plus 6 because you are multiplying here, minus 6 because you are dividing, and minus 2x because you are dividing. So if you simplify, this will give you 3 exponent 6, which is 729. The second question, it's a little bit different compared to the first because of the minus sign, which means in the numerator and in the denominator you have two terms. And once you have two terms and a fraction, most likely at some point you will take out a common factor and some things will divide. So if you look at the first term in the numerator, you can reverse the product rule there. If you reverse it, you have 3 exponent x times 3 exponent 2. You can reverse the product rule in the denominator as well, so that you have 3 exponent x and 3 exponent x times 3 minus 3 exponent x minus 3 exponent minus 2. At this point, you can take out a common factor, which is 3 exponent x. And if you simplify, 3 squared minus 1, that is 8, because 3 squared is 9, 9 minus 1 is 8. And in the denominator, you have 3 minus 1 over 3 squared, which is 1 over 9. And if you simplify, you get 26 over 9. If you put this in your calculator, you get 36 over 13. The third question is a combination of sets and exponents. So because you are multiplying here, what you need to do is you can put this under the same square root, and if you do that, you will get 200. 20 multiplied by 10 is 200. X exponent 5 times x would be x exponent 6. It's important to also note that in the denominator, the x exponent 6 is outside the square root. So 200 can be written as 100 multiplied by 2. That is a square multiplied by a prime number. So that simplifies to be 10 root 2 because the square root of 100 is 10. And then if you take the square root of x exponent 6, you have x exponent 3. And now you can see that in these two terms you have something common. It's roots 2 and x cubed. You are left with 10 plus 1 in the numerator. And then root 2 and root 2 will divide. X cubed will divide x exponent 6 such that you are left with, this should be 11. 10 plus 1 is 11 over x exponent 3. Moving to the second question, this is where we look at equations. We start with a very simple equation. You have 1 over 16 times x exponent 3 over 4. So you have rational exponents equals to 4. So what you do is you multiply both sides by 16 so that you get rid of the 16 in the denominator on the left hand side. So you are left with x exponent 3 over 4. And if you say 4 times 16, that's 64. 64 can be written as 2 exponent 6. And then because on the left hand side you want to have x exponent 1, you raise it to the reciprocal of the exponent. So the reciprocal of 3 over 4 is 4 over 3. And you do the same on the right hand side. So if you multiply 6 with 4 over 3, you get 8. So you have x equals to 2 exponent 8, which is 256. The second one in question 2, you have x exponent minus half equals to 1 and a third. So the first thing is that you must rewrite the mixed fraction, which is 1 and a third, into an improper fraction. So that is 4 over 3. And then, because we want to have x exponent 1, because we are solving for x, we raise it to a reciprocal once more. So the reciprocal of half is 2, but because our half is negative, we must also make 2 to be negative so that our 1 is positive. And then you must do the same on the right hand side. So if you simplify, you have 2 exponent minus 4 over 3 exponent minus 2. Now, you can apply the negative exponent rule, which means the 2 exponent minus 4 will go to the denominator to be positive or to have a positive exponent. And then you take the 3 exponent minus 2 to the numerator to have a positive exponent. And then your final answer will be 9 over 16. The third one, you have 2 terms. You can reverse the product rule there. So you separate 2 exponent x plus 1 to be 2 exponent x times 2. You do the same on the second term. You take out a common factor, which is 2 exponent x. Then you are left with 2 plus 2 squared. That is 6. You divide by 6 on both sides. You have 2 exponent x equals to 1. You rewrite 1 using the 0 exponent rule. So you have 2 exponent 0 equals to 2 exponent x. And because the bases are the same, the exponents are also the same. The fourth one is a surd equation, a simple surd equation. So in this case, you know the first step, you must isolate the surd, which means that the term with the square root must be left on its own. So you transpose the 4 to the right hand side, it becomes minus 4. Then you must square both sides. If you square both sides, you get root of the square roots on the left hand side, and then on the right hand side you can write it as 2 brackets. Now you multiply out and you are simplifying at this stage. You transpose the x plus 2 to the right hand side. Then what you have is now a standard form. You factorize, you make sure you check that the signs work out and that you get your middle term, and then you get your x equals to 2 or x equals to 7. But you are not done. You need to check your solution. So you take x and substitute it back in the original equation at the top, and you see if the equation balances. If not, as in this case, then you come back here and you reject x equals to 2 by stating that it is not a solution. The third question, which is the final question for this test, you are given root x over x plus y over root x. So if you look at your denominators, this will be your LCD. So a smart way of doing this is to multiply with a special one such that you get your LCD. So in the first term, we multiply by root x over root x because x times root x will give us our LCD. We multiply by x here because it will give us our LCD again. But again, this is 1 as this, which means we haven't changed this expression. Now you must also remember in this question they said show. So it means you know the answer that you are working towards, and you must use that information to your advantage. So you see, if you say root x times root x is x, x times root x is root x, and then on the second term y times x is xy, root x times x is x root x. And because now the denominators are the same, you can take one denominator and add the numerators. And if you look at the two terms in the numerator, they have something common, which is x. So you take out x as your common factor. But if you remember, your answer had a denominator of x and not of root x. So it means at some point you need to rationalize and multiply by root x over root x. Now this x, which was a common factor, divides with this one and you get 1, and you are left with root x and you are left with y plus 1. So if you rationalize by multiplying with root x over root x, you get what you were shown to prove, and that is root x multiplied by y plus 1 over x. Thanks for watching.